Good evening, everyone. I am the Mad Computer Scientist. Let me move the mic over a bit closer. On this channel, I discuss math, computer science, and tech topics that are of interest to me. On Friday nights, I do something a little different. Okay, that's working good. Should have muted that before testing that. But on Friday nights, I do something a little bit different, and we try to go over people we think aren't using good logic. Now, I'm not really sure that Terrence Howard is using good logic. His math is terrible. I know we'll have some Terrence Howard fans tonight, and yes, I'm sorry, but saying 1 times 1 equals 1 breaks both the fundamental theorem of arithmetic and the
2.
fundamental...
Saying it equals 2.
Yes, correct.
See, like your brain automatically does it, right? Your brain it sees the stupid and it's like, oh no, that can't be right. Let me just fix that for you. And you're like, no, I meant to say that.
Listen, I have no problem accepting that 1 times 1 equals 10. Or because of Boolean algebra that 1 plus 1 equals 1.
Yeah, I mean, but he doesn't know what any of those words mean, including the word 1, like literally.
But
anyway, I interrupted your spiel, I think.
That breaks both the fundamental theorem of arithmetic and the fundamental theorem of algebra, but he does have the best math proof I have ever seen, and I want more math proofs to invoke conspiracy theories. Tonight we have Dr. TapiocaWeasel joining us. If he would like to introduce himself.
Hello, I'm Dr. TapiocaWeasel. I am a physicist. We covered Terrence Howard on Bad Science Sunday, which is a show that I am the co-host of with Maya Adkison over on Maya's channel. And this guy. So yeah, he broke me.
And with that, welcome to Faulty Logic Fridays, everyone. And you are free to point out faults in our logic. Do not think you are not. All right, let's get into this. Let me know if he's doing chemistry because I want to skip that.
We use the same simulator that they use at Princeton. And we took linchpins, and we haven't even introduced linchpins yet, but it'll be a great introduction for it. We took linchpins, this configuration of where...
what is a linchpin?
Where 6 pentagons meet.
Oh.
That is a good question. For those of you who don't know, linchpin is his drone project, and I am pretty sure the physics of how he thinks these will work are wrong, because I'm pretty sure drones that push against air do not work in near vacuum environments.
I never actually watched the whole thing. Because I don't hate myself normally. He wants that to fly in a vacuum.
Yes,
he wants something to fly in a vacuum as opposed to be propelled by a rocket in a vacuum.
Well, he doesn't. Sorry.
Does he understand how vacuums work?
He thinks space is not a vacuum, and we're going to get into that.
Oh God. Okay, that wouldn't work in air. I'm looking at it. That would barely work in air. They're all facing you don't need to make it that complicated. What are you getting for that's a lot of extra mass for a bunch of propellers that at any given time you're not going to be using because you're trying to go in a particular direction. And so the ones that are just perpendicular to that aren't going to be very helpful.
Well, he did hire engineers to design a drone with that basic shape for him. He's going to claim he designed it, but he did not. He hired a bunch of engineers and had a project.
Okay.
And we put them in particular order. There's a link for that right inside of the thing that James Pellegrini sent over to you. If you'll pull that up, and we rebuilt the planet Saturn.
What?
Without gravity.
Okay, I'm just going to
in his simulator. Okay. Sorry. Go on.
I'm just going to speed this up while you're doing that because we want to get us through as much of this as possible.
Yeah, no, for sure. This man. What is the first half of that sentence didn't connect to the second half? What is he talking about?
He's going to show us in a couple seconds here, but I want to make it clear he's going to use Blender, which is not a simulation software. It's a 3D animation program. And a bunch of people went through the animations and have found that he's claiming not to have used gravity, but the animations, and especially the script for them, use a force that is pretty much gravity and uses the same values.
Oh my god. Oh my god. I've never used Blender. I know the Dapper Dino uses Blender. Oh my god. Okay.
Yeah, it's just an animation, but like many programs, you can use Python to extend Blender's capabilities, and he claims that he does this without animation in Blender, which is a false claim in itself. And he's claiming not to use gravity while using a force that suspiciously acts the same way as gravity.
I'm not convinced he knows how to do any, like, does he know how to do coding or rendering? I mean, at all? Does he know how to use Blender?
I'm guessing based on his math, he would not be a good computer scientist or programmer.
Well, I'm like, yeah.
Because while I can get the computer to tell me that 1 plus 1 will equal 2, and 1 times 1 will equal 2, and even be doing the math correctly, I don't think he knows how to do that.
And it has the rings with no animation. It has the rings and the hexagon that's observed.
Okay, I'm just going to interrupt here because he just said a program that is specifically for animation has no animation. Just in case anyone missed that.
At the very top of it, without dark matter, without dark energy, without gravity, showing that it's an outward force pushing down that creates the planet. If you can pull that up, and he explains it out, it's like 3 minutes long.
And where does the matter come from?
He used, well, the matter, remember, that's condensation. If you were to picture, before we watch it, let me explain something. If you were to picture the waves at the ocean, you know, the darker the waves, the deeper the water, you can't see a distinguishing fact between them until they crash into each other. That splatter, that little foam that comes out.
About? This isn't coherent, like, thoughts.
I honestly don't know. So just, say something like stop when he says something you're not sure what he's talking about.
Yeah.
It lasts for a couple seconds, and then it settles back on there, and it's just the balance between this force and this force. That's the physical universe. Those few seconds that it takes that matter, that more dense water, and the foam to recoalesce and get balanced again with the surrounding environment. That's the entire time that our universe, or all these universes, have worked together. But if you play this is at the very beginning of my book. That's why I went on that at the Emmys, and I was like, look, I've got something else to do. I've been able to rebuild Saturn without gravity, with no animation, and then they clowned it.
Of course they did.
Well,
this is not something that you could say in a sound.
Oh my god. I don't. What? He's talking about seafoam and it's the entire universe? I don't. Why? Why is he like this? You're muted.
Why is he like this? I'm not entirely sure. I've been running off the theory without trying to diagnose him that he's suffering from some untreated mental illness.
Yeah. Yeah, I think so. It's because unless he was like always like this, which still maybe then, but like the guy's a famous actor.
I have another theory that is based on my years as a gamer and the fact that my favorite, World of Darkness game was Mage the Ascension. I think this is a multi-year addition to play as Son of Ether. Because the Sons of Ether, now they're the Council of Ether, were a group of mad scientist mages who didn't like the fact that the group that was controlling consensual reality did away with the ether. So they broke away and joined the other faction. But you would have to do a lot more about the old World of Darkness than is healthy to really understand what I just said.
Fair enough. All right. I kind of want to see. Does Joe show the animation here?
Yes, he's about to show it.
Okay.
Did I start? Oh, that's the wrong.
I
hit
do
the
that
wrong
all the
button.
time.
which is one of the reasons why I wanted to talk to you. This is not something like your explanation of these things and your description of the very nature of reality itself is not something that should be taken lightly.
No,
Oh, yes,
It's
it
something
should.
that like
thank you for saying that.
it needs to
Yes,
be
it
laid out
should.
and it needs
What
to
are
be
you
slowly
talking about?
examined.
No, it does. There's nothing here to examine. Everything he says is just obviously on its face, in actuality, complete nonsense. He doesn't start by demonstrating a thorough grasp of physics. And it's not because all of physics is wrong. Like, I would love to see this guy actually go out and do some physics. And with predictions, precise ones, and comparison to a model, this is stunning.
Have you ever read his classic masterwork, 1 × 1 = 2?
I never read the whole. I couldn't do it.
Before
I watched a video where Neil deGrasse Tyson presented his like review that he did for the guy, and he went through it. So I sort of watched like a YouTube video where Tyson went through it, and I was like, wow, this is. I basically at every point was like, yes, Neil, I agree with what you are saying, and you were doing an extremely polite job.
Before he takes a physics class, he's going to have to pass some elementary school math classes, and based on what he's written, he wouldn't be able to do that.
This is correct.
And because you've obviously spent a lot of time working on this. This thing here. So play this, Jamie.
Play it. And this is us.
What, Jamie?
Just to clarify what I'm going to
Yeah,
play.
and turn it up.
Hold on.
Yeah,
There's two different videos. One's long, one's short.
No, this is going to be the short one.
My computer just reset itself too because all
Okay.
these files freaked it out.
Oh
The
yeah.
government, man.
I don't know. I was about
Well,
to play
they
this.
don't-
Neil deGrasse Tyson. He
Yeah,
knows
what's
where your
up?
They do
computer
not
sits.
video.
Oh
It'll be
my
the
God.
first one.
I was just laughing at that.
This one, correct?
Gravity is an effect.
Okay.
Is an effect
So
of
this is-
electricity. So
okay.
turn it up. So
It's not. There's no way to make that work. There's just no way to make that work. That you have to completely misunderstand one or the other at the very best. And generally it involves misunderstanding that and like literally everything else too. Okay. You're muted again.
The good news is that physics and math aren't the only things he misunderstands. For example, do you know carbon sexuality?
No, what?
Carbon is bisexual.
Oh my God.
He actually said that.
Like you. Oh. Okay.
I
don't
don't
know
know.
This guy's so stupid.
Judging by what I think he was trying to say, I think he was trying to get at something in chemistry like certain elements are more likely to form ionic bonds, and the other type of bond, which I forget because I didn't like chemistry and just decided this is not for me after taking it in 10th grade. But I think that's what he was trying to get at, but he didn't understand it.
Chris does a full narration of it.
Oh, it's still hold on. My computer's still.
And he was talking to my wife and explaining to her what he had worked on, and this is 6 years ago, I think, or maybe 5 years ago. But as soon as it allows you to,
Let's see.
The center.
rewind it just a little bit. Yep,
Okay, here we go.
it's just 3
I
minutes
have two
long.
groups of vortexes.
But can you
There's
full
the
screen?
Tornadoes.
Oh, yes,
Spinning
sorry.
Tornadoes that are pointing towards the center.
Give me a second.
As I highlight this object here, you'll see it, that yellow line. Right, so there's a bunch of those in there. There's actually 16 of them, and I'll highlight them
Oh,
all.
hold on. It's not doing anything. See, it's
No, it's about to happen.
no,
It'll
nothing's
come
happening. My computer just froze again. Is what I'm trying to say.
Oh,
Something
it's-
freaked out by my computer.
Yo,
I have to just try to.
Joe
No,
Rogan,
you-
get your shit
I'm
together.
Oh, okay.
I think it already did. I'll try again. Hold on. We have to pause.
Yeah.
Okay, no worries.
I don't know if Titan is here yet, but if you do get here, if Legend of the Eternal God shows up, just remember if he says anything that violates terms of service, just time him out.
Yeah, that's what it should be doing. But it's going to basically, you'll see.
Oh wait, that's weird. I have. I can,
What's the matter?
what I can see on that screen is not what I can see on my computer screen. I can't even see that.
It's the fucking government, man.
You think?
Oh, yes, there is some IT stuff I want to address because he's going to say something about his phone if we get there. But it occurs to me that his phone was just set to time out after so many seconds, but he thinks they are turning it off because he disproved basic math.
It's
Oh,
not.
I think it is sometimes. I assume they listen to everything I say.
They do.
I'm sure.
They do. You
It's a
took
lot
a
of boring shit.
You're one
You
of the
took a bold
biggest
stand, though,
podcasters
years
in the
ago.
world. You might be the biggest single podcaster in the world, Joe Rogan. Okay, a lot of people listen to what you say. You can't act like that's a shady thing.
I think he was trying to be funny. He was on news radio after all.
That's true. Yeah, I think Joe Rogan is always hamming it up. I don't think he's nearly as stupid as he pretends to be.
when the governments were trying to poison their citizens. You took a very
Okay, I'm going to skip the COVID denial,
Yeah.
and I think this is where it's
Jamie?
starting.
All right, here we go.
this is rebuilding the planet Saturn. Go ahead.
Go ahead.
The sound was coming through your speaker. Is that what it was?
Wow.
Time for a new laptop?
Yeah, just
You know what's going on.
Okay, earlier in the podcast, he did say something about his phone. And this is another issue where, hey, I have a CompTIA A+ certification, and I'm pretty sure what's going on here is the person hit the function key that disables the laptop keyboard, and if you just hit function and whatever that key is, the keyboard would come back on. There's no government conspiracy theory there.
Yep.
Government.
They do not want you. We're about to kill gravity. We're about to kill their god, gravity, and
I would pay to see that.
they don't
Oh.
want that.
Towards the
Here we go.
center.
Here we go. From the beginning.
I have two groups of vortexes, which are just like tornadoes, spinning tornadoes that are pointing towards the center. As I highlight this object here, you'll see it, that yellow line, right? So there's a bunch of those in there. There's actually 16 of them, and I'll highlight them all. There. I'm going to do that just so you can kind of see a little bit better. So they're all pointed towards the center, but they're arranged in what we call the linchpin configuration. I'm going to pretend like you never heard of that before. So there's one on the top, and then three in groups of three around that are spaced at 120 degrees apart. And the tilt of these ones on the bottom here is 109.5 degrees in relationship to the top ones. They're creating this flat space on the top and the bottom. And they're spaced at 120 degrees radially. And then inside the model is three groups.
Jamie, there's two sounds playing simultaneously.
Oh, yes, just so everyone knows, that was on the Joe Rogan podcast. It is not on my end.
While he's
That's
doing
my
it?
wife talking. We're in the kitchen, and he's just explaining
okay,
over
okay,
Skype.
Recorded from the
This
Skype
is
call.
over
Okay.
Skype.
I was confused. Go ahead.
Up to 1,000 pounds, from 2.2 pounds to 1,000 pounds. And there's no gravity whatsoever in this model. There's no center attractor. So it's just vortexes and two.
Wait, correct me if I'm wrong, but the center attractor would be those vortices the way they're aligned, right?
Dude, I don't know. I don't know what he's talking about. What are the vortices for? Why did he have this configuration? Why is he doing any of this?
I get the feeling that a lot of the people around Mr. Howard just humor him, like the programmers knew how to generate this, and they just came up with a script that fits Howard's script, but I'm not sure.
None of this has been explained why any of this is doing it. Like, there's no context. He thinks that this sounds smart, and he's like, we've got this model. You haven't given any model. Like, can you explain in words a little bit about what you're talking about that are coherent? And then I'll be like, okay, I see a vortex thing. I think that's what he described as the other thing. Like, what are you?
Yeah, well, it's in the center, though, and he said there's no center attractor. It's like those vortices would be the things attracting it to the center.
I maybe if like, what are the vortices though?
But this is also Blender, so it's not a simulation. It's just an animation that's designed to do this.
Two
Yeah,
magnetic fields, a north and a south polarity, and one harmonic resonance, which is emanating a vibration in the field.
What?
in this region here where these vortexes
All
are.
right, go ahead.
That didn't mean anything.
A lot of people think a lot of what Terrence Howard says means something deep, and it either doesn't mean anything, it's word salad, it's flat out wrong.
What do they think it means to mean something in this context? He's trying to model Saturn without gravity. Like, so you does he know what Saturn is?
No, and he also doesn't know what the red spot on Jupiter is.
Oh God, okay.
They're pointed, so it kind of just oscillates.
Hopefully we will get to that, because when I saw that, I'm like, I don't even know physics, but there is no way these theories about planet formation are correct.
Give it a little
All
bit
right.
of randomness in motion so that the particles will kind of interact and bounce around like smoke or water, waves and water. And then when I hit play, it does it all by itself using physics simulations. So there's no animations at all in this model. And when I play it,
There's
It's
no...
a-
Sorry, go ahead.
It says play animation.
I was going to say, there's no animations at all when you're using what is animation software.
Yeah. Wow.
this is what pops out.
Holy fuck.
Wow.
And then when I look down at the top, it makes the actual hexagon that NASA has observed on the top of Saturn.
I personally think that Saturn does actually have that, but I think it's on the southern pole. It's actually kind of cool.
I think it is on the North Pole. It might be at both poles.
Could be that as well.
Without any gravity. And you'll see
I-
that you get a surface.
What are we looking at?
We're looking at someone animating a Saturn-like planet in Blender.
Okay. What are all these little dots?
Well, I'm going to say pixels, but I think they're just supposed to represent random matter.
I don't. Was that explained?
No,
Okay.
of the sphere on the inside with the heavier particles. So the colors.
Are you basically saying, is this saying that you guys can recreate planets?
yeah, that's
Yes, this is a particle simulation of the physics involved in making up the planet Saturn.
Wow.
Like all the
It is a particle simulation of the physics involved in making the planet Saturn. Are you sure it's just not a Blender animation?
yeah. So the heavier particles are creating the red and the green.
Can I pause this for a second?
Yeah.
So is he saying that just by doing these calculations, he created the exact form of Saturn, including the rings?
Just the exact form of it.
Just with the
Okay, you just did not see or hear the mad computer scientist facepalm badly at that one.
I have not. This is all. It's not even. It's barely nonsense. It's nothing. It's just nothing. I don't. What are you talking about?
Someone used a program to create a shape that looks like Saturn. That's all they're doing here, and they used a Python script to try to model supposed actual physics.
I don't think they did. I don't believe them.
the
So you
calculations.
changed
I would not find that hard to believe because Blender integrates Python scripts fairly easily.
the angles of incidence that these linchpins, because remember, each one of these are opposing vortices. So there's 12 vortices to this that are opposing. So one,
And the engineers who got that to actually work, or the actual drone, say it's a rather inefficient way of doing it.
Yeah,
what-
no, this is a
once the
horribly inefficient design. It doesn't make any sense at all. It's complete nonsense.
of incidence change. You can
Angle of incidence has to do with light.
you change the motion and pressure conditions. You can
I have no idea what he means by that.
No,
now
he's just-
change the
Yeah, no, it's completely unconnected. The thing, the idea, the words he's linking together are just totally unconnected from themselves. There's nothing even here to respond to. It's crazy.
condition or the crystallization.
Well, to be fair, we have more than one person in our particular circles that is relatively confident in how they present themselves, but anyone who knows what they're talking about understands that they don't really know anything. Like one of the most famous is Kent Hovind,
Yeah.
who has the best doctoral thesis ever.
Station.
Yeah.
It all So I was saying with a periodic table, now because we have the angles of incidence, material engineering.
Okay, I guess the periodic table has something to do with Saturn because elements are made out of molecule or matter.
Can now separate the space between carbon and nitrogen or carbon and boron and have the same elements of titanium, vanadium, chromium, magnesium, and iron.
And for those of you who wondered, Terrence Howard claims to have gone for a chemical engineering degree at an institute that didn't offer one at the time he went there.
Nickel, cobalt, nickel, copper, zinc, gallium, or germanium in those higher octaves. We can do that between silicon and phosphorus or silicon and aluminum. So the transparent aluminum now becomes possible because we can now control.
Actually, I seem to have... Sorry, go ahead.
I don't know anything about chemistry, so like
It's probably just gibberish. We can skip ahead again. Let's see if we can go ahead and get the transcript and go to the best part, I think. Because this Saturn thing just isn't that interesting.
Involved in making
Yeah,
up
just
the
for
These returning waves meet expanding waves. That's when we get our first geometry. So this is a proof that the universe
Our first geometry?
what the hell are you talking? That's I've never heard that's not how the word geometry is used.
is not infinite, but finite, because you could not have shape.
We don't know if the universe is infinite or finite.
Yeah, I personally think it's infinite. I think that makes way more sense.
Without the returning waves, and the waves would not return unless it was bouncing off of the edge of something.
Look how strange that is.
Bingo.
Look how strange that hexagon on the top of this of Saturn is.
I do like Joe's response here because when I found that out, that is legitimately cool because you don't get so close to a regular polygon in planetary shapes like that.
Yeah,
Normal.
yeah, it's kind of you need some funky like vortex action going on there.
Mhm.
Or yeah, that's Saturn, right?
Yep, and then
Yeah.
we don't even, and
That
he,
is so
he
crazy.
explains exactly how he built it, all the angles of incidence, all the pressure
What the-
systems that he used.
What do angles of incidence have
It doesn't
to do
mean anything in this context. I mean, it doesn't mean anything. It means nothing.
All of that is so it can be a repeated experiment, but they've ignored this. This is in the beginning of
A simulation is not an experiment by itself. A simulation can verify data if you run it through a supercomputer, like we have done that with tornado formation. But experiments generally require a bit more than just going through a computer, unless you're doing something like data science.
my book. You go to my book, that's the first page on there. Before you even open it up, I've got this, and we rebuilt the Milky Way galaxy the same way, and it predicts the star arrangement better than NASA does. And this is without dark matter. This is without dark energy. This is without the standard model. So
Is dark matter, dark energy, are they primarily theoretical?
that's all theoretical.
Are they?
No is the answer. No. Dark matter, we can map it. We have several different lines of evidence that suggest very strongly that it is a particle of some type. And we have a lot of different projects. I'm actually also part of one that are like designed to detect and find various potential types of dark matter. All of those require that it interact in some way that like isn't gravitational, or if it is only gravitational, that it be like of a certain type. Like it has to be kind of large, because otherwise we're never going to find it other than the ways we've already found it, which are gravity, but that's not helpful.
Well, honestly, if you said non-baryonic matter, you'd probably ask about Barry White or something.
Yeah.
Theoretical. They've never witnessed it, and we couldn't prove that Michelson-Morley experiment.
Oh, I just want to point out, because this is part of his bad math, as if he wants to prove Euclid wrong, his hoodie that he's wearing says the square root of 2 equals 1.
That they did in 1887, which said that there was no effect because they tried to move a table around and change the angle of incidence for light to see if the light changed.
Wait, what? I don't think that's the Michelson-Morley experiment.
Is that what he's trying to describe? That literally did not occur to me
Yeah,
until. Okay.
he is trying to describe the Michelson-Morley
Like,
experiment.
can you back it up a little bit?
Yeah, let's go back.
You can also use arrow keys. They can be easier sometimes.
Or J and L. That also works.
The edge of something.
Look how strange that is.
Bingo.
Look how strange that hexagon on the top of this of Saturn is.
All of that is so it can be a repeated experiment way, and that's all theoretical. They've never witnessed it, and we couldn't prove that Michelson-Morley experiment that they did in 1887, which said that there was no effect because they tried to move a table around and change the angle of incidence for light.
Okay, for those of you who aren't total physics nerds, the Michelson-Morley experiment disproved the ether.
Yeah.
To see if the light changed when you move the table. The experiment is like this. A mental experiment is like this. If you're
The Michelson-Morley experiment was not a mental experiment.
Yeah,
Experiment.
it wasn't, and it wasn't about like he doesn't know. It was an interferometry experiment that was testing models of how light propagates. They thought that it had to propagate with a medium, and they thought that like it. If you just mean space by ether, which is not what they meant, then like people nowadays have all sorts of ideas for the ether, but the ether had properties, and one of them was that if you moved like fast with respect to it, then you'd be able to see that in an interferometer. And they didn't see anything. They didn't see, they were, you expect a signal of a certain size, and it didn't do that. And then it has to be combined with other models of ether, because like you could have a stationary ether model, but then there are a lot of other things that don't make sense then.
It would
Like
be
stellar
easy.
aberration. Sorry.
It would be easier to stop on the things that do make sense.
Yeah. No, he doesn't know how these theories worked and how modern theories work. He just simply has no idea what he's talking about. And he's talking about physics here. He's talking about my branch of physics. Yeah.
Listen, I've had people tell me that because I have a computer science degree, I shouldn't comment on math, as if there's no connection between computer science and math.
That's ridiculous.
A structure, and you have an idea of how A behaves, and you have a thought that if you put A in a particular situation, it's going to turn into B.
Oh, also, chat, I have a question since he brought this up on another podcast. What is Kurt Gödel most famous for, math people?
So let's picture it hypothetically, like you
Are
have
you asking?
a ball.
Because his incompleteness theorem.
I was asking the chat because there were mathematicians there.
Oh, well, yeah, it happens to be I'm pretty sure. Yeah, I don't.
Yeah, if anyone can show me where he did any work on the identity property, I'd love to see that, because I have not been able to find it.
That's maybe 6 inches long of iron. And you say, okay, well, I think if it goes into the freezer, that it's going to get shorter. So you're supposed to have 2 exact bars, 6 inches.
Wait, I think you said something that was correct.
Yeah.
Some elements can track. Sorry, go ahead.
He's describing an experiment right now, and so far he's doing it correctly, which I'm stunned by.
Out and leave one outside of the freezer, and put one in the freezer, and then you compare them after you see it. So A over X is equal to R times B over X. R is the result or the change between them. B is the change that occurs. R is what fraction or the X that you use in order to get back to A or to convert it to B. What they did with the Michelson-Morley experiment, because they could not get out of the ether. They couldn't step outside of the ether because it's everything around us. So
it is very hard to step outside of things that don't
exist.
Yes,
exactly, which is why it only disproves certain models. Yeah.
They couldn't tell a difference, whether they saw no result, no change. So they assumed there was a void, that there was no ether there. And
okay, I can tell Mr. Howard has never had any math class beyond Algebra 1, most likely. But I don't know if this works the way in regular experiments, but in statistics, what you try to do is disprove your null hypothesis.
And that's when particle physics took off. Lorentz, a great physicist that
Wait, what?
everybody loved, entered a paper in 1904 where he was continually explaining the ether the same way that Maxwell, all of his theories came off of there being an ether, but he was still limited by
No, they didn't.
Newtonian laws. And
No, they didn't. They came off of observations. They did not come off of there being an ether. They came off of observing that the electric and magnetic fields behaved in this way. The Maxwell's laws do not posit an ether. They simply don't. They describe the relationship between electric and magnetic fields and electric charge, and like that's what they do. They do not posit an ether.
David Hodge, no one is saying mathematicians can't be self-taught because autodidacts exist, but you actually have to understand basic math, which Howard does not.
and the column force of opposites attracting, when it's the positive, it's the things that are alike that attract. But he believed that the ether was still and space was flat. And so space-time.
I know you'll probably want to say something about space being flat.
I mean, space is mostly flat, but I can't. I'm not. I don't have like. It's an idea that's completely unconnected to reality.
And the idea of flat space does not mean space is not three-dimensional anyway.
Yeah. The universe does happen to be quite fascinatingly flat on the large scales, which is interesting. But locally, it's not flat. Like you on Earth, like you have to. It's pretty hard to detect it most of the time. You need either really good clocks or something like that, or you have to be really unfortunately close to like a black hole. But
I don't think Mr. Howard realizes that.
what he doesn't. I don't think he. In 2 seconds, I don't think he'll remember half of the words in the previous sentence. So sometimes maybe, but
Time or Einstein relativity came as a result of them taking the ether away. And for 100 years,
that's sort of true. It's more that what Einstein did with special relativity was I think it was to realize that the ether was not necessary, and that if instead of starting with that model, you sort of start a little bit more basic and you start with I guess it's not more basic, it's an alternative sort of way of framing things, which is just that the speed of light in a vacuum is the same for all observers, because so far there was no evidence that demonstrated anything otherwise. Like it all sort of, unless you interpreted certain things with this ether framework, but then you had these contradictory experiments. Like if Michelson and Morley had showed a positive result, then you would have this would, like, ether would have made a lot more sense, and but it didn't, and modern day versions of it don't. So and the modern day versions of these things are not rare. Like there's a lot of other experiments that have interferometers in them they would all be sensitive to this. LIGO is an enormous interferometer. It would be way more sensitive to this, and as the Earth goes around the sun and stuff, you would notice it. And as the Earth rotates, if you had that type of ether, it would 100% notice it. It's able to notice way, 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 way more small things, like black holes colliding on the other side of the fucking space.
Okay, I'm just going to address something in chat for a minute here. David Hodge, I do occasionally touch on religious topics on this channel, especially on this particular show, but that's simply because religious arguments tend to have a lot of bad logic.
Yeah, I mean, I wouldn't rule out, maybe somebody did intentionally create the universe. I don't know how that would have happened, but I suppose it's possible.
Well, it doesn't even matter.
Yeah, right. It doesn't really concern me unless they have some personal interest in, my business, and I find that exceptionally unlikely.
Yeah, some of Terrence Howard's ideas do seem to come from spirit science.
This particle physics world, that's all theoretical. And here I've patented these.
particle physics is not all theoretical.
Yeah, it's not. There's a lot of
Wave
experimental data, bro.
conjugations. That is the ether, is the contraction of the ether and the expansion of it. And on top of that, the proof of it was I've been
Okay, this is something Mr. Howard also doesn't understand, although he does seem to grasp that you can prove things in mathematics absolutely. He just doesn't understand that if people don't accept your proof, it's not going anywhere, which is why no one is saying 1 times 1 equals 2, Howard. You were doing bad algebra, and that's why people rejected it.
Yeah. I mean, he wasn't even doing algebra. Like, he's doing like weird pseudo philosophy.
Well, he was trying to do some math, and it's clear he didn't understand what he was doing. Like,
able to build new
also, he doesn't understand what a balanced equation means in math either, unsurprisingly.
industries from it. If you go to, I want to introduce the linchpin, if I can.
Didn't we already do that?
With all of the talk,
Before we do that, can you tell me how a planet is formed under this theory?
Oh, yes.
Oh.
You may want your face protecting oven mitt out for this one.
Oh,
Just a warning.
You have a sun, and how does the sun give birth to these planets?
the same way we defecate and have gas, like Jupiter's.
Oh my-
that
What?
red spot.
Yes, he just said that.
Okay. He's trying to explain how the sun formed, how the sun and the planets formed. What is he trying to explain?
He just said planets are formed the same way we defecate and have gas.
They come out of a rectum? What?
Let's finish what he's saying, because it doesn't get any better.
On Jupiter,
Mhm.
that's spinning on it, that's
Mhm.
going to become a moon. It may take a billion or 2 billion years. That will ultimately become a moon off of Jupiter. Where is it? Right at the equator. Where do we discharge at? Right at our equator.
Yes, so planets are formed the same way we defecate. He just said that.
Oh God, I hate this guy.
All right. First off, any Earth science course should have taught you the basics of planet formation, and that is not correct. I mean, I'm guessing based on what you've said, Mr. Howard, that you are not, let's say, probably in the highest classes at your high school. But I'm pretty sure the classes that they give people who might not have college as their plans do cover that information. I'm sure even you heard the phrase planetary accretion disk. Or am I wrong?
I don't know. A lot of schools have bad teachers, I suppose. And even more have bad students. So maybe he's just completely incapable of, learning.
Possibly. Yes, but he's also going to say where he thinks planets start out at.
And then it will rotate its way around and slowly be pushed out by the solar wind by Jupiter.
So like coronal mass ejections.
Coronal mass ejections.
So some kind of ejection of matter leaves the sun, and over billions and
Planets are not formed by coronal mass injections.
They're not.
Ejections, sorry.
They're formed from accretion disks. We can see this happening in other planet things, like planet forming stars, protostars. So we can see this happening. We have a lot of models for it that are done with simulation, with like big, particle matrix grid simulations. And there's a bunch of theory about it. There are various different regimes of planetary migration that we understand, and like how planets can like change their orbits and go inward and outward. And again, we are able to observe these things. So there might be scenarios in which you could have a highly unstable like massive star that could throw off enough stuff, like technically in terms of mass, that it could coalesce into something. but that would be a very, very rare situation. And generally, if like a really, really large star shedding material, it doesn't. It's all like hydrogen basically and helium, and it doesn't coalesce that well, but unless it's like a larger amount, and it's probably it needs to get outside of that environment anyway, so that's going to like take a really long time. But you don't just get blobs of stuff that's not what these things are made out of. They're not the core of a protoplanetary thing. You have like a nucleus spot of heat. You might have like a bunch of solid stuff at the beginning, but once you've got a star, like an actual star, no, it all like vaporizes. So
He is actually about to do some correct math as well, which is surprising.
Billions of years, enough of it collects, and there's enough of a force
to where ultimately that coalescing idea that they have, that's where it happens. It's not
Coalescing idea?
yeah, they do more like
yeah.
planets do yeah, I mean,
Is it possible?
accretion, coalescing, yeah, it's fine.
Is it possible he's misunderstood the idea of a supernova and how new stars form?
Like the thing is, if he's saying that the star blasts out other like that doesn't happen. The only way that might happen is if like you had two like whack into each other really hard. That would be awesome, but I don't know how often that happens. It's not very common.
No, I meant that this gases are pushed out and moved to a new location.
Yeah, and they can create shockwaves, and they can also add material that is coalescing elsewhere. Yeah, they can definitely do that. Yeah.
But I think that's more science than Terrence Howard has ever had, personally.
Well, none of his scientific ideas are anything more. They don't make any sense.
From materials that's just been left over from the Big Bang, like Rupert Sheldrake says, that
I have no idea who that is.
I also do not.
Physicists of today ask for, you give us one miracle and show us how everything came from nothing and we'll explain everything else. And they can't explain everything else. They can't explain the morphic resonance that's happening.
Morphic resonance?
I don't know what that means. It might mean something. I don't know, but there are resonances in various senses, I suppose, in terms of like the universe. Like the observable universe has a certain size, and it has, we live in a universe with some topology, right? And space is a thing that can move and expand and curve and vibrate, and it does so, and we have sort of plotted out how kind of lumpy space is, and not just that, but how that lumpiness has changed and how sort of the universe has vibrated. And there are sort of low order modes that I suppose you could call resonances. But they're not resonances though. There are a few, the angular power spectrum that you can see in the cosmic microwave background does show some peaks, and we have very good explanations for those that require dark matter to exist, by the way, because they're, dark matter based explanations. And those do by far the best job with the least amount of extra sort of assumptions at explaining things. But I don't know what a morphic resonance is. I could Google it.
Maybe it has something to do with the Mighty Morphin Power Rangers.
Between things like right now, because I've discovered these wave conjugations, every person on the
wave conjugation.
Who is this David Hodge guy in chat?
He has as far as I can tell, I think he has a math channel.
Okay, because he's saying that like he thinks that Terrence Howard makes sense, and I find that very interesting. And he's saying that I don't he doesn't make any sense to me. That's for darn sure.
Planet that's been thinking about it will now have ideas concerning, but not just us, but all humanoids throughout the entire universe will now get that same resonance.
What?
Oh, this is morphic resonance. Yeah, no, morphic resonance is the thing where if well, the example that is often given is like if a certain group of well, in his example, I suppose people like learn how to do a thing, that information or knowledge is sort of intrinsically transmitted to, you know, the other things that you're attuned to, which are like other people. And so that yeah, that violates a number of things in physics. So if it could be demonstrated, that would be fantastic. But you can't. There's no way of transmitting information that we know of faster than the speed of light. The closest thing that could be vaguely sort of compared to this, which is categorically not a transmission of information faster than the speed of light because it doesn't involve transmitting any information, would be like quantum entanglement stuff. But you can't use that to transmit information.
And for anyone watching this who might believe Terrence Howard, it's okay to say, I don't understand quantum mechanics. I don't understand quantum mechanics. It's not what my training is. It's counterintuitive. And a lot of it is just weird.
Yeah. And I mean, I don't understand cosmology that well. I had to spend some time like learning more about it because I'm like, my specialty is quantum mechanics. So like, and atomic physics. And so like whenever they start explaining how they think atoms work, that's the part that it's like, it's so much fun because it's like I'm better there than anywhere else at like finding ways of shoehorning what they're saying into maybe a kind of vague thing that at least each statement on its own can sort of kind of make sense, but then they don't work together in any way that matches reality.
Well, I assume I'm correct in assuming someone with a PhD in physics knows more about physics
Than him? Yeah.
than someone who's working on their master's in computer science.
You would hope so, but you know, there's some dumb physicists out there, so I wouldn't bet on it.
Well, having a degree, as Ben Shapiro demonstrates, doesn't make you smart.
Like, yeah.
And be able to apply it like the experiments with the rats.
Right.
You teach a rat something here and
Honestly, if this were true, it would have made discrete math and calculus so much easier.
Yeah, I mean this. I'd have to because I think he sounds like he's referring to actual experiments, and there may be actual experiments. A lot of these things like don't work again when you try and replicate them, or at least when anybody else tries to replicate them. Sometimes you'll get like people where their experiment works, but then nobody else does it. It happens in every discipline. It happened in physics in the early 2000s with this guy Jan Hendrik Schoen, who like was publishing all these awesome papers in like Nature and Science, and he turned out to be a fraud. So, and they, you know how we know? Because we checked, because that's what science normally does.
Listen, I like fields where you can 100% prove things.
London, and then in New York, you find the rats are doing the same thing.
Okay, rats do certain behaviors.
No, he's talking about a new behavior that they were taught.
I don't think this is true.
I don't. Yeah, I don't know.
Simultaneously because of the morphic resonance, because we are all connected on this ether, and that waveform that's the consciousness. We are all just one great being.
Oh, for heaven's sakes. There is a huge discussion about the nature of consciousness because of programs like ChatGPT right now. But if you ask most computer scientists, they'll tell you, no, what we're doing isn't consciousness. And they will tell you it doesn't really matter because all we're trying to do is simulate human intelligence. Sorry, bit of an off-topic rant there.
Yeah, I mean, I have no idea what's required for consciousness.
You know, that's what they forget. We're not separate. The universe is probably one cell.
The universe, okay, it depends on what you mean by cell.
Inside of some superorganism.
Right.
Okay, there's no way we have of knowing that.
And we're just
Yeah.
little who, little who's like Horton hears a who and trying to make sense of it. And
Yeah.
it's a beautiful thing that we're making sense of it. But everything is just one great being. We're all God. That's what Jesus was talking about. That's what Buddha was talking about. It's recognizing
Buddha, who, if I recall correctly, actively discouraged worshipping God, said he was a god? I'm going to have to verify that one. And I'm pretty sure Jesus, according to Christian theology, just said he was God.
the divinity in you. What I did as a child, I said, I'm going to, instead of waiting for the Messiah to show up, what if everybody picked up their torture stake and behaved and did the things that they had expected the Messiah to do? What if everybody just for one day walked around and behaved as if
Wait, did he say torch and stake?
Torsion steak or torch and
Torch and
oh yeah,
steak.
torch and steak. Okay. Yeah, he meant pitchfork, I think.
So we're going to kill Jesus? I don't think he thought that one through.
Is he a Christian?
I have no idea. But it makes it sound like we're going to kill Jesus the vampire the way he said it.
Yeah.
they were God himself and did the things that they would expect a creator. And we know God can't just be a male because no man can produce a child without a female. Everything in the universe, as above, so below, like Billy Carson always.
Have you ever read Frankenstein?
Yes, I have. I wonder if he has.
Not relevant, but
talks about. You can't, everything has an equal and opposite. It has to mate.
no, it doesn't.
Yeah, I don't. Why? Like, that's certainly not a law of physics.
Mating is a big part of what we do.
Well, at least that part's true. Mating is big part of what a lot of people do.
Yeah, that's true.
Boron mates with nitrogen, and that's how the carbon
Boron does not mate with nitrogen.
happens. Everything inside of us, all our cells, they're mating. There's a relation.
Oh, for heaven's sakes, Howard.
Yep.
I guess we can add middle school biology to the list of classes he needs to pass.
Going on in it. Everything's alive. There is no death, but that the Bible.
Everything's alive except for the things that aren't.
Talked about a mechanistic world. God took dirt and blew into it the breath of life, and it came to life. But if you look at the Brownian effect, what is breathing? Going from positive to negative.
What?
And they see all
the Brownian effect.
Is he trying to bring up Brownian motion? Because I have no idea.
If he is trying to bring it up, it's not recognizable as Brownian motion. But okay.
Well, considering he thinks the associative and commutative property is a thing in math rather than two different properties.
The associative and commutative property are two different properties.
Yeah, he thinks they're the same thing.
Oh, okay.
Makes these things up are still going from it's still carbon polarizing from positive.
Okay, I'm gonna skip a couple minutes because he's going through chemistry that he's also misunderstanding.
Yeah, okay.
Let's go about to the 1 minute 40 mark.
Just roll through.
Sony, Microsoft, Amazon.
Okay, I am going to bring up his patents because people have looked at what patents he has. He does, in fact, have some patents. He does not have a patent on VR because he was born in 1969 and the first virtual... Sorry, go ahead.
I was just saying nice.
And the first virtual reality patent or first virtual reality application was developed in 1968. He does have a few patents on designs for kids' toys and a few patent applications for jewelry. His patent for VR was rejected.
Hewlett-Packard.
Yeah.
Keep going.
Okay, let's get past this because his patents do not prove he's a genius.
No.
Now that I was going to talk about in a second.
I do want to say that would probably be a cool video game.
But it's an unlimited source of power. But-
So
Your
What's an
drone,
unlimited
which-
source of power?
let's go back about 10 seconds and see if we can find out. Go back a little bit more.
see which one is this. This is 4 of them that's going to come together to pick up a barrel.
and what's powering them?
Right now, we're going to use hydrogen fuel cells, but I have another system, that I was going to talk about in a second. But it's an unlimited source of power.
Okay, so he's not going to tell us what it is.
Okay, yeah, I guess. I mean, hydrogen fuel cells are not like a thing that is working yet. I don't know what the deal is with that. I haven't heard about hydrogen fuel cells in a long ass time.
And even if they were working properly, why would you use them to power drones? Batteries work just fine.
Yeah.
All right, let's continue.
But-
So hydrogen fuel cells,
Or you can use lithium batteries.
and
at
they're
present.
how are they moving? Like, what are those? Is that like are those like propellers?
Yeah, those are props. But
Okay.
but that right there, what we have right there is it's a pitch. Collective pitch. So instead of the props having to turn themselves around,
Mm-hmm.
instead of all the
Someone spoke out about what he's doing, and they actually had to have a complicated controller and a bit of software to do what he's saying they're doing.
Yeah.
having to turn themselves around.
But they just get more inefficient the more they get together. Because the thing is, they're not going to contribute more to the thrust and the power. The thrust and the power is going to scale probably worse than I would say probably worse than the linear size of the thing, and the amount of mass that you need is scaling up as the cubed length. So those things get less and less effective the more they group up, because of just the way the physics and the geometry of how they move through air. And then with that weird propeller organization, they already don't have a very efficient sort of way of doing it. What you need to do in order to use a whole bunch of little drone things to lift a bigger one is that you need to have them all be able to still pull the sort of cross section of air that one would pull, and then multiply that up. And putting them all together like this does the opposite of that. So they get sort of weaker.
To stop and turn in
yeah.
the opposite direction.
Like a
They
helicopter.
just switch the direction.
Oh.
So it's a collective pitch and it changes. And so now instead of going up,
I really wish Spotify would have forced fact checkers on Joe Rogan.
you're going down, and now 5 of them will come together there. And watch what the 5 does with. So this is the
Okay, all you're showing us is an animation, which honestly, this would be a cool start to a video game.
Yeah, those, it would work a lot better if they all just stayed separated.
Because in a video game, you can create whatever physics you want.
Oh.
this is the and how many is necessary. And they can, since this is the fractal, they can be as small as a nanoparticle, or they can be as large as the universe, because the entire universe.
How are you going to make them as large as the universe?
Yeah, it would make way more sense to just use a regular quadcopter design and have them all link up, and then have the ability to change the pitch of the propellers on the insides, or well, I guess you don't even need to do that, but that would make a lot more sense. Just using a normal quadcopter design and having those all link up, that would be way more efficient.
Comes down to this. So I was trying to reach out to Elon Musk. I was trying to reach out to Jeff Bezos. I was trying, because my
Okay, I know people will not like me saying this, but Elon Musk is not a genius.
No, he's not. I mean, I don't know that Jeff Bezos is a genius either. I mean, geniuses are rare. So
Well, the problem with Elon Musk is people would have still thought he was a genius if he would have kept his mouth shut.
yeah, probably.
The problem is he kept like buying these industries and kept announcing stupid ideas. So
Yeah,
you
I mean,
know,
yeah.
until he got to Twitter, I might have accepted he was a genius, but then he said the dumbest stuff about software design. Sorry, go ahead.
He made he was one of the people that was like involved with, what was it, PayPal or something at the beginning? What was his even role in that though?
I think just a financier because I've seen some of Musk's early code. He wrote it when he was a teenager. I don't want to be judged by some of the Pascal programs I wrote at that age either. But apparently he wrote some code for another website that essentially it was all scrapped because it was inefficient and they had to hire new people to do it.
Heh.
So that's probably why he thinks like it's a good idea to fire your software engineers who write the fewest lines of code, rather that a good software engineer will probably come back and rather than do their naive algorithm with a lot of code, will find a way to write it in fewer lines of code.
Yeah.
My main goal was I was building these to clean up the upper atmosphere, all of that debris that's up there, and
They will not go into space. They will not clean up the atmosphere.
ultimately to mine the asteroid belt.
Even if they could go into space, those drones would take centuries, probably, to get to the asteroid belt.
I mean, yeah, and they would run out of fuel. There's not a lot of room for fuel.
Because you can't go out there. They keep talking about going out there. That's like
They can't go out there. We've landed asteroids on comets.
Yeah, I don't know what he's talking about.
Oh, I think
Maybe.
he means.
Will
Sorry,
he explain?
not very well if he does.
try and go that far away. That's like taking a starfish from the bottom of the ocean and bringing it up to where we are. Everything expands. The nitrogen expands too much. That animal dies. You take us outside where Mars is, nitrogen has expanded so much more. The hydrogen has expanded so much more that you will never be able to, you won't.
Is he
I don't
trying
know
to describe the
what-
bends?
I don't know what he's trying to. Can you go back and let him re-say that?
All right, I went back 40 seconds.
Because the entire universe comes down to this. So I was trying to reach out to Elon Musk. I was trying to reach out to Jeff Bezos. I was trying, because my main goal was I was building these to clean up the upper atmosphere, all of that debris that's up there, and ultimately to mine the asteroid belt. Because you can't go out there. They keep talking about going out there. That's like you try and go that far away. That's like taking a starfish from the bottom of the ocean and bringing it up to where we are. Everything expands. The nitrogen expands too much. That animal dies. You take us outside where Mars is, nitrogen has expanded so much more. The hydrogen has expanded so much more.
Yeah, I mean, fundamentally, there's no. Yeah, it gets less and less and less dense, and eventually, it just you're just in a vacuum. Like, yeah, that's why balloons pop if they just keep going up and up and up. Unless they're strong enough to hold in the stuff, which like the space station is a balloon with very thick like steel walls instead of rubber.
All right, I'm just going to mention this because I think it's cool. I have a friend who has a bachelor's in physics and a master's in computer science, who's a software engineer who has code on the International Space Station.
Oh, that is neat.
But yeah, I don't think his description of what happens to starfish when you take them out of the ocean is correct. I'm also pretty sure starfish don't live that deeply in the ocean.
Yeah, there might be a few starfish. Like I think there's a lot of different kinds of starfish, but it does happen to like fish and stuff that are from real deep water. And yeah, it's definitely like not good. But you don't pop if you're put in a vacuum though. You do get a lot of like messed up skin stuff though. And your lungs will probably come out of your like throat with a lot of force or something, but it's pretty rough.
I'm also pretty sure when people come up from the ocean too quickly, which is what the bends is, they don't explode like he was suggesting. It's painful, it can be lethal, but people are still pretty much the same shape when they come up.
Yeah.
You will never be able to, you won't even have a spaceship or a suit on that's strong enough to keep your body together, and you will never be able to come back to 93 million miles away from the sun, because everything will have expanded, and you will expand to the point of vacuity.
That's
And
not it,
explode.
you can't just keep on, like, it doesn't turn into negative pressure. It That's not how it works. Like, there's a certain amount of pressure, and if you take it all away, you can't keep taking it away. So
Before using phrases like negative pressure, I think Mr. Howard needs to accept that negative numbers are a thing.
oh god, yeah, that too.
Out. So trying to send a man out to Mars is like trying to send a man to live on Venus. The pressure is too
No?
tight near Venus. We will get crushed.
It is on the surface of Venus. The pressure on the surface of Venus is pretty crazy. Venus is like shockingly inhospitable.
Yeah, but sending a person to Mars and sending a person to Venus are not like each other. If we send
Well,
someone,
I mean, Astra, like, in terms of this, like, orbital dynamics, they're not that different.
but in terms of the pressure at the surface, they are very
Yeah,
different.
yeah, they're very different there. Mars almost doesn't have an atmosphere; it's very light.
It's like being pushed to the bottom of the ocean immediately. You will get crushed immediately. The pressure conditions change as we move from the sun. But science have neglected that because they've said it's a void there. And they don't account for it.
Well,
It
it's
is
a near void.
Yeah. It's empty space. I mean, yeah.
I think he's misunderstood the idea that there isn't an absolute vacuum with the idea of whatever is going on about here.
Yeah.
That higher pressure condition, but they found that radioactive decay is quicker closer to the sun, near Venus. Why?
Okay.
No, I've never heard of that.
I've heard maybe one study suggesting that, but I don't know that the results have been replicated.
That seems, yeah, that seems unlikely.
And usually stuff like that turns out to be a problem with the measurement or some instrument.
Yeah, you can sometimes get weird measurements. Or there might be some systematic error. Like, sometimes the measurements are right, and then you have to, like, figure out why. Like, the Pioneer anomaly was a very famous example of that, where Pioneer was sort of accelerating slightly differently when it was coasting, because they do accelerate a little bit, because there is some stuff, for one. There are a few atoms every so often, for one. And then you're also getting radiation pressure from all the different light sources that are around, and you're also getting outgassing from your thing, is like sending off particles. And they modeled it, and like they were like, okay, it should be moving like this, and instead of moving like this, I can't remember what the thing was, but they eventually sorted it out, and were like, oh, okay, yeah, there was this effect that we either didn't think about or something, or like had incorrectly calculated.
Yeah, I think there was something a few years ago where they thought they had faster than light particles at CERN, but it was just an error in the instrument.
Yeah, it was a like a fiber optic cable that was loose, and none of those people work in physics anymore.
Well, the person installing the fiber optic cable should not be working in physics anyway, most likely.
I honestly, I've had a lot of times when I've plugged in a thing slightly wrong, and their problem was they weren't able to find it. They didn't manage to figure out a way of finding it. They probably knew that they were wrong. They were like, we messed up, but we searched really hard for how we messed up, and they didn't find it, and so they were able to publish. But they looked, and then they did find it eventually. I mean, so
Yeah, they didn't say this was right. They're just like, we're pretty sure this is an error in instrumentation.
the pressure condition, that electric field and those magnetic fields are pushing on each other, causing it to turn back into an electric force in comparison to further away. When
Wait, what?
I don't know.
in the sun, when the Earth is closer to the sun, they found that radioactive decay is quicker than when it's further away from the sun.
No, they've never found that on the Earth.
I don't know what he's describing.
He's trying to say when the Earth is closer to the sun, radioactive decay is quicker.
Like, depending on where you're observing it from a different location, you will have a small amount of gravitational redshift, but he's not being clear about. I need to like hear some more specific citations and some numbers. I mean, gosh, but he's not famous for his ability to use numbers well.
Wait, you want to see more of Terrence Howard's numbers? Why?
No, I don't. I really don't.
I spent most of the summer arguing with people that 1 times 1 really does equal 1.
Ugh.
Is that by accident? Or is it just because of the change of pressure conditions? So us talking about going out, when my wife said on the thing, are we going to be able to put people on Saturn? No. It's
Ah, yes, the very famous scientific citation. A thing my wife said.
it's too nebulous. It's expanded out too far. Our pressure, we would have to have a suit so strong and powerful in order for us to do that. But linchpin is able to make it out there because we have another propulsion system.
Yes, the things that push against the air will be able to make it out to Saturn.
Propellers, a brand new propulsion system
that we've put together, where I'm able to take water and put it into a small change. And this patent has been granted. It's the propulsion projectile. And we patented it as a gun because I didn't want anybody else to be able to use it like a gun. But it's basically lightning in a bottle. We take water and we put...
Wait, patenting something as a gun doesn't prevent people who buy it from using it as a gun.
Yeah, he means like to manufacture a gun based on that like thing. Like they won't sell, and somebody else can't use your like thing and then sell a product if you've patented the thing.
But if I just go out and buy this gun thing he's talking about,
He's not going to sell it. That's the point. He's not going to sell a gun thing.
Or if I make it and don't sell it.
Yeah, that's true. You could make it yourself, but then you're just making your own homemade gun, which you can already do. He's speaking out against arms manufacturers. I actually do see where he's coming from here, and I applaud the sentiment.
Put it inside of a small chamber based on the wave conjugations that I have and the angles of incidence.
Okay, I would love to know about his wave conjugation.
I don't know. Every time I hear wave conjugation, I flash back to my high school Latin classes and start going OST, mostis, NT.
Okay.
Because conjugation is either something that bacteria do for their version of sexual reproduction, if I recall correctly, or something you do to a verb.
Yeah.
And we run an electric charge through a small amount of water. The water is not able to expand into gas like it wants to because it's locked into the pressure condition. So immediately it converts into plasma, and it converts the gas dimension into a power dimension. So it's light.
Wait, can you have water plasma?
It wouldn't be water. I don't know. I actually don't know if you can have water plasma. I don't know how that would work. I don't know if you would just have the hydrogen and oxygen and stuff dissociate and you'd get something else first.
I remember asking a chemist about this once, and she said that no, you can't have plasma chemistry, which seems right, but I'm not a chemist.
Yeah, I wouldn't bet like categorically you can't, but I would bet that almost always you're gonna have, because you can have like a water ion, and then you could have an isolated ion of water in a vacuum, and then you could have a bunch of those moving around, and then I suppose you have a water like plasma, but it would be but that's not like what you get if you just if you just like heat up water like in a normal because the thing is water just goes off on its own. I think if you put it in a vacuum kind of anyway. And so that's why water boils when you put it in a vacuum.
Okay, he also just said he was going to run electricity through water.
Yeah. I mean, that is a way to that's how electrolysis works. And the problem is it's very expensive in terms of energy. And the reason it is because like all of that energy that you're getting out of these hydrogen fuel cells when you burn hydrogen and oxygen together and you just make water, all of that energy, you have to start with hydrogen and oxygen. Where are you going to get your hydrogen and oxygen? By breaking apart water. Guess what? You're going to lose energy in that thing because that's how thermodynamics works. You're not going to be able to cheat the system. So it makes great fuel. That's what rocket fuel is. Hydrolox is like the best rocket fuel for unless high density is really, really important. When high density is really important, then hydrogen is not very dense, so even liquid hydrogen.
So yeah, I'm just bringing that up because I'm thinking maybe he doesn't understand the difference between plasma and gas. Because if you run electricity through water, you will get a gas.
You'll also get like if it actually starts sparking, like there's a plasma in that region, but I don't know how that works. I don't know if it just breaks all the atoms apart immediately. I suspect so.
Sorry, that was an accident on my part.
That's fine.
Just from water, and there's no end like with.
So it's a real lightning gun, like
Yes.
Quake.
Yes. So, and the patent's been granted. Typically, you're limited to how much charge you can put inside of a cartridge, and you have to get more and more charge or explosive in there to get something out. But with electricity, you can send 1,000 volts or 1,000,000 volts through the same aperture, and that water is incompressible, and so it's just going to react, and immediately it converts into a plasma, and so we can project anything into space. All of that has been accomplished and it's ignored.
So he's talking about basically using he's talking about pumping a lot of electricity through water and it explodes.
I guess.
Maybe if you pump enough electricity, yeah, like if you put a lightning bolt through it, it's gonna, yeah, a lot, yeah, but that you're not going to want to launch a rocket that way. We already get pretty aggressive with how we use water and hydrogen and oxygen to launch rockets. It's basically already a controlled explosion. Like you're not going to get a whole lot more out of this.
I just have a question from the audience here.
No, I'm not answering this absolute maniac's completely moronic question. And I think that you should ban her.
I'll let Titan.
Go on.
I'll let Titan handle that when he shows up. Because we all know the YouTube laws that if Titan, whose full name I am not saying, ever shows up in chat, YouTube automatically hands him a wrench.
So it can act as a propulsion system for rockets as well?
Rockets, anything, and in space. And that's the whole point for it because there's just nothing but moisture and that collective and ice in there. So you can now, the linchpins can go all the way past Mars, attach themselves to whatever asteroid, mine that asteroid, bring it back, and have in one of the Lagrange areas. So for the audience.
Yes, but there are tolerances with most electric devices about how much voltage they can take. Because voltage is electrical pressure, Mr. Howard. If I remember correctly.
Out there, Lagrange areas are those areas where multiple magnetic fields meet, and there's no weight to something.
That's not what a Lagrange area is.
Another death blow to gravity was the fact that it's not a constant. It could not be.
Wait, gravity isn't a constant?
Well, the gravitational constant is a constant. Gravity, like the effect, the force, the word gravity is not a constant. The gravitational constant is a constant. I don't know what that means, or what he means.
I think he means gravity isn't a constant, like it's not always there. It's like, I don't know.
It's not always there if you go somewhere where there isn't much gravity, right? So in that sense, it's not a constant. Does gravity just like turn off? Not as far as we can tell.
Okay, for the benefits of people watching it later who don't already know this, I assume most people do, a Lagrange point is a place between gravitational fields where the forces are balanced, so effectively you have near zero gravity at that point.
Yeah, and it's also you're sort of comparing it to two other bodies in the system. If you're placed at that point in an orbiting system, you will not move relative to your already sort of pre-existing condition in the rotating reference frame of the system. So like if you have an object between the Earth and the sun at the right point, and like ignore the moon for a moment, it still like works, but you know, it gets harder to visualize. There's a point where it will stay like at the same distance from both the Earth and the sun, mostly the Earth, because it's sort of the smaller thing that sets it. But yeah, I don't know if
The
there are
constant-
Lagrange points in highly elliptical systems. Actually, that's not like immediately obvious to me. Okay.
Well, this person thinks that Pythagoras and other Greeks thought the Earth was flat, so
because things weigh heavier on the poles of the Earth than it does on the surface of the poles than it does at the equator. They're
hey, he got something right.
heavier at the poles than they are at the equator. And the further away
But it's a very small difference.
from the Earth you go, the less it goes. So there's no consistency about gravity. It is not a constant. It is a coefficient, and it's more so just an effect. And it's the same thing with the
I would love Terrence to define coefficient.
yeah.
Planck scale. You look at the Planck scale or the Planck.
Planck scale? That might be a thing, I don't know.
That is a thing. Yeah, you can basically you can define things, new units that make a bunch of physical constants equal to 1, and then you can just do a bunch of math without ever having to worry about the physical constants. This is what theoretical physics always does, because it's way, way, way easier theoretically, but then when you actually go back and need to put in some of the numbers and then use it in units that, you know, people actually understand, then it gets more complicated again. But it means that because you're not really worrying about the units, you can just set like mass is equal to length. But that's not a thing that means what Terrence Howard would think it means when I say that. So I hesitate to even say that.
Hey, if Terrence Howard is dealing with the values greater than 1 when dealing with things that are being multiplied in my bank account, I will go with his math. Anything smaller than 1 or things that go below 0, we'll go with regular math.
Indeed.
So someone had a question in chat. Why are Newton's law of gravity and Coulomb's law so similar?
Yeah, so they're similar insofar as they both, in both Newton's law and Coulomb's law, you have the force decreasing as the inverse square of the distance. Why fundamentally is that true in both cases is not something that I really know a good answer to. It at least not like a basic answer. There are these, so gravity that emerges like when you actually, Newton's law comes out when you actually do the predictions of general relativity in the sort of low mass limit. And the electric force comes out of sort of the electromagnetic force generally. So it's like, because that's what, Maxwell's equations sort of say. Fundamentally, they both sort of obey what's it? What's the equation? Is the Laplace equation? Might be the Laplace equation that I'm thinking of. I'm so bad at like math. I should be better at math. I've been doing too much physics for the last 2 weeks. That is like not my bailiwick, so my brain is fried.
That's okay. On this channel, we don't do so much math as we do logic to get the computer to get the right answer for us.
Right, exactly. So there's not really a great, fundamental reason that I can give. It's just sort of, the world works in the way it works sometimes. And we try and describe more and more of it using less and less entities that are necessary, basically.
Or it could be that Colin was just looking over Newton's shoulder when taking a test.
Yeah, it could be.
Planck length or the Planck weight, all of those things are based upon gravity, and they're supposed to occur at 10 to the 15th, 10 to the minus 15th, the Planck scale. But at 10 to the minus 35 is where the proton and all of that behaves. They have gravity inside of there as if it's affecting.
I would love to know. Sorry, go ahead.
Go on. I was just moaning.
He just keeps saying where that behaves, and I would love to know what he means by that. Does he mean, certain things happen at these? And he's just throwing out numbers. I think they're supposed to relate to energy levels, but...
Yeah, it could be. Honestly, my brain's starting to get fried.
But they've already said that at a small molecular level.
That's okay. I should have recommended certain recreational pharmaceuticals, if they're legal in your state, to handle this guy.
At the nuclear level, gravity has no effect. So how is that part of a Planck scale?
I don't know if it has an effect or not. I think it's just that if it does have an effect, it's too small to measure.
Yeah, that's the problem with gravity, is it's very, very weak. There are attempts to try and measure it on smaller and smaller scales, and there's some stuff that we don't know about that should be maybe possible to get some experiments working. We don't know what happens exactly if you put a quantum object in a gravitational in a spatial superposition. Do the different parts of the wave function attract each other? It's not exactly clear how that works. But because gravity is so weak, it's very hard to make experiments that do that.
And of course, this guy thinks he has the grand unified field equation. I'm going to put it in chat so everyone can enjoy this one. TapiocaWeasel, let me know when you want to stop. At 2.5 or 2 hours and 30 minutes, it just goes into something irrelevant again anyway.
So. Okay.
There's a guy, Fleming, that talks a lot about this, but you take that, you look at the speed of light.
Yes, and what I just put in chat, according to Mr. Howard, is the grand unified field equation.
1 to the power of 3
equals pi. Oh, sorry, I got that wrong. Let me fix that. It's 1 cubed equals the absolute value of pi. I don't know.
Is that a constant? In 1928, they saw that there was different fluctuations between 1928 and 1948 between the speed of light, and then out of nowhere, and Rupert Sheldrake talks about.
Well, yes, there are fluctuations in the speed of light, depending on the medium it's going through.
Yeah.
This out of nowhere, they began to be a constant again, where there were fluctuations before. And he asked one of the professors about it, and he said, "Oh, it's a thing that we call intellectual phase locking, where when they get different measurements for the speed of light, all of the scientists around."
No, he's describing a thing, but he's describing. I think I know what he's talking about, and he's talking about a real thing, but it's not. It was not this thing. So what happened with the measurements of the speed of light? Like they measured the speed of light a lot, and the measurements were sort of had like decent, kind of like largish error bars, and we're all at a particular value. And then one group finally was like, okay, we are measuring it and we're not getting this number. We're getting a different number. And they published that number. And after that, most of the measurements were more around that new number, and they started to get smaller and smaller and smaller error bars. And the reason for that was that some people did get sort of stuck in the idea that the speed of light was at a certain value, and so when later groups would measure it, they were like, I'm not sure, that doesn't make sense. Like they would keep on quote unquote like tweaking and fixing their experiment until eventually they were getting the other value, but they always had to like kind of, do things a little bit weird, or so the error bars never really were getting smaller because they weren't actually improving. They weren't really doing science very well because it was still the very early days of physics. This persisted like kind of a long time, and after like a new group put out a thing, wow. Okay. Sorry, I was looking at what just popped up in the chat. And that's why nowadays when you do precision measurements, the best practice is to blind your results. So what you do is you do all of this analysis and you have a random number that's sort of added to it. So you don't know what the actual final outcome is, and you do all of your systematic checks and everything like that. And then you unblind, and that's what you learn. That's only after you've completed your analysis do you learn like the actual number. And my advisor in grad school, both of them, they both work on the same experiment. They do this for their measurements of the electron-electric dipole moment, and they're trying to measure a number which, if they measure 0, that makes a lot of sense, and if they measure non-zero, that's a huge deal, which is why people are trying to measure this thing, and they will spend months very carefully calibrating their machine, and then they take all this data, and there's a file that has a number which is like locked with like none of them ever see it. It's created randomly, and they don't open it until the end, and whenever they do it and make a new measurement and churn all the data and come up with a thing, they have an unblinding party where they unblind the data, and remove that number that's sort of being added to their result, and that's the number that they have to publish. And it's very stressful, but also exciting. So it's a way to keep out the bias, and it's something that was not around and still is not done quite as often as it should be, I would say.
Was this a randomly generated number?
Yeah, but like in the vicinity. So like the number they're trying to measure, the new bound on it is like 1 times 10 to the negative, or maybe it's like 7 times 10 to the negative 30 in electron centimeters, which is the unit. And the number that they will like be working with and stuff, because they need to have something to like look at. I think it's on the order of between 2 and 3 times that value, because it's they know roughly, they know with a certain limit what it will be, but it could also be negative, by the way. It could be, it's one of these things that could be a negative number. It's symmetric about 0, but
Well, no,
Yeah.
the reason why I was asking is because computers don't really do randomly generated numbers very well. Although we've gotten closer with things like trusted platform modules. I don't know if it would affect their experiment, but... And I wanted to address something in chat here, because I think there's a misunderstanding about the grand unified field theory is a way to unite quantum physics and general relativity. So if there's an equation, to estimate it, it will not be 1 cubed equals the absolute value of pi, because that's not, well, that is an equation, but there's no variables there.
Yeah, it's not a physics thing. And also, I'm confused. Does David Hodge think that 1 times 1 times 1 is not equal to 1? Because, like, I mean, I don't think you and I are working with the same definition of multiplication, buddy.
I think there are certain maths where you can get like something that's fairly close to pi doing it, but even in computer science, if you get something like that, you're dealing with floating point wonkiness,
Yeah.
where computers just don't handle floating point numbers very well. But it's beyond the maths I would learn as a computer scientist, and I think it's some subfield of probability. But the mathematician can correct me.
On the world will average it out to one thing instead of showing the fluctuations in it.
Oh, wow.
It's called intellectual phase locking. It's
But
not
is that
called
also because of
fudging.
the crude methods of measurement that they have
No.
available?
No, they've been able to measure light, the speed of light, since Galileo was measuring Io.
Wait, what? I'm pretty sure that's not even correct history. Because I don't think the speed of light was measured until, what, the 17th century? 18th?
I can't remember. Hold on.
It wasn't Galileo's time. So we'll do... Sorry, go ahead.
Yeah, when was it? Sorry, you were saying something.
I was just saying, let's Google it.
Yeah, Romer. So Romer used that was the first quantitative measurement, and he used differences in when like Io showed up when observing Jupiter. A very ingenious method, actually. His estimate was correct to within like 50%. So he was correct to like an order of magnitude, which is hard to do when you're measuring something that appears infinite. Like before him, nobody did. Like it could have been 10 times faster. No, we wouldn't have known.
Okay, one thing I wish Google would really stop doing is insisting I want an AI search bot. I don't want something that's even less accurate than Google search results. That irritates me to no end, and I don't know why Google thinks that's a good idea. But
I like it when I Google things that I already know and I need to be reminded, because I can recognize the right answer, but I can't remember it.
But it does look like at least the first speed of light measurement did take place in the same century that Galileo died.
Yeah, I was gonna say I don't think it, because Galileo died. When did he die?
1642, I think.
Okay.
And the speed of light was measured by Romer.
So Romer was like the first guide. Fitzo is the measurement that Bradley. I didn't realize Bradley did it with that, but
yeah, it looks.
if Fitzo measured it with a wheel, it's really cool.
If Google's right, the first time it was done was 1676. After Galileo's death, but still the 17th century.
Yeah. Yeah. But I mean, he didn't do it in a lab. He just did it. He was off by 27%, I guess.
Going around Jupiter. And that's how they came up with the speed of light, was how he watched Io going around Jupiter and saw that there was a difference in how the light.
What he's describing is Romer's experiment, yeah.
You got something right again.
Yep.
This makes me want to take a drink, but I don't have any alcohol.
Behaved. And they've been able to get very close measurements to what they thought was the speed of light. But it's never been a constant because it changes depending upon the medium it's going through. So there's no constant there, but they have that as part of the Planck scale. But the linchpin, the wave conjugations, the tetryon, it's the end of Planck. It's the end of Schrodinger's equation. It's the end of Heisenberg's uncertainty principle. And
How would that end Heisenberg's uncertainty principle?
I don't know. I don't know what any of this guy's saying. I think I'm at my limit though.
Good enough. We
Oh,
can end this because that was Terrence Howard on Joe Rogan. He was wrong about most of what he said.
yeah, not absolutely everything.
Some of it touched on maybe real physics, but he went off and misunderstood it.
Yeah, I mean it pretty rarely, honestly. When he was describing true historical facts, that was the closest he got. But like when he's describing his own sort of ideas, they're incoherent.
He got his own name right. Well, I guess we can give him that. I did enjoy him in the first Iron Man movie, let me be clear. I do think he's a good actor.
Yeah, I don't remember how. I haven't seen that one in a while, actually. I should rewatch that. That's a good movie.
I think the reason Don Cheadle replaced him is because he realized that 1 million times 1 million was 1 million. Well, technically, if you want to add the units, the way he thinks he's doing it's 1 million squared, which doesn't necessarily mean anything depending on what you're doing, but
Well, I mean, it means a trillion.
or that. If you want to interpret million as a unit, which rather than the number.
Well, no, 1 million the number times 1 million the number is 1
Is
trillion
1
the number.
trillion, yes. But if you're treating the 1 million just like one, if instead of the number, never mind.
Yeah, I suppose,
making-
but then you don't know the difference between 1 and 1 million.
I am being as coherent as Terrence Howard. But $1 times $1 is $1 squared, not $2.
That's true. Yes.
All right, so this is the last video I'm going to do on Terrence Howard for a while, because I have had my fill of his bad math. I could only stare back and look at the physics like, I'm pretty sure this is not correct. An action times an action does not equal a reaction.
Yeah.
What he's trying to say is an action has, sorry, let me get it right. For every action, there is an equal and opposite reaction, which is not a mathematical statement. It's just one of the laws of motion.
Yeah, you can formulate it mathematically, but when you have a collision, you have the same forces acting on both sides of the collision.
Hey, listen, here we like to express things in powers of 2 anyway.
Yep. Wow, it's been great fun.
All right. So, Dr. TapiocaWeasel, if you'd like to say where you are and put out anything.
Yeah. I do a show over on Maya Atkinson's channel called Bad Science Sunday, and it's fantastic. And I have to remind myself, let me see if it's immediately present here. What our next show is. But Maya, what's our next show? Because my internet is like calendar thing is I'm bad at the stuff. So yeah.
I thought it was this Sunday, but
It is this Sunday. It's every Sunday at 9:30 Eastern. And we have Mark Reed. There we go. I actually found that right before I saw her type it in the chat. I swear. I found the thing. But yeah.
I believe the channel he's on is called Maya Atkinson.
Yeah, if you go to yeah, Maya's channel. She's in the chat, but unfortunately you can't go to like people's channels from chat unless you're a mod, which is super annoying. You should totally be able to do that. But if you Google, yeah, or if you YouTube search Maya Adkisson's name, or I think it show. I don't know if it shows up if you do Bad Science Sunday. I hope so. I normally don't I'm on it, so I don't do a whole lot of watching it unless I'm not on it, which is pretty rare. I was not on it 2 weeks ago though.
Maya, you have a wrench, so you should be able to put a link to your channel if you so choose.
Boom.
And
Oh, PZ Myers does a show or did a show called that. I didn't even remember that.
I am the Mad Computer Scientist. You are on my channel. We are at 222 subscribers. We want to get to 256, which is when I'm going to do the next Ask Me Nearly Anything stream. There are some questions I won't answer. So, like, comment, and subscribe. Go out and check Maya's channel. I do not know if TapiocaWeasel has his own channel.
No, I don't have content on my channel. Like, I have a channel, and you can find me. I'm Dr. TapiocaWeasel. But you can subscribe. Go ahead and subscribe. But I have never made content. I have no plans to make content. If I get 1 million subscribers, I will make content.
All right. Have a good...
Sorry.
Have a good night, everyone, and go out and write some code.
See ya.